Okay, hi everybody. So today we're going to go over the rational root theorem. Sorry everybody, I've lost my voice. I think it's probably allergies. Anyway, so the rational root theorem. Um, this is not a very fun one by any means. It's actually not fun at all, but it can come in kind of handy in a pickle, I guess. Okay, so let's go over the definition. I know it's not going to make a whole lot of sense, but I'll explain it. So if f of x is a polynomial, so you have some sort of a polynomial, f of x is equal to and x to the n plus blah, 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 all the way down to the last one, which is a naught. This is the leading coefficient, and this is the constant term. Okay, so if f of x is a polynomial with integer coefficients, so integers is like -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on. And if P over Q is a 0, so a 0 is a value that when you plug it into this equation makes it equal to 0. On the other hand, it's also the place where if the polynomial, when you graphed it, looks like that, a 0 is a place where it crosses the x-axis, so either one of those. So if it's a 0 of f of x, then P is a factor of the constant term f of x. So P is a factor of a naught. And Q is a factor of the leading coefficient right here. So Q is a factor. Okay? And so all this is saying is if there is a rational root of this polynomial f of x, it's going to be in the form of P over Q. Okay? So let's go through this. Like I said, this isn't so much fun. Okay, so we have this polynomial x cubed plus x squared minus 10x plus 8. And what I have to do is I have to figure out, okay, what is going to be the 0 of this. And so all I have to do is look for all the factors of the last one, P. Okay, so P are all the factors of the constant term. And Q is a factor of all the factors of the leading coefficient. So P is going to be plus or minus 1, plus or minus 2, plus or minus 4, or plus or minus 8. Those are all the factors of P. Okay, Q can only be equal to plus or minus 1 because that's the only number that's there. So P over Q is going to be plus or minus 1 over 1, comma, plus or minus 2 over 1, comma, plus or minus 4 over 1, plus or minus 8 over 1. So if it has a rational root, it has to be in that form. And it definitely has a rational root because this is a cubic polynomial, which means it's like that snake one that we always talk about, right? It looks like that, which means it has to cross the x-axis. Okay, so the best thing to usually do is start off with 1 or -1, okay? So if you start off with 1 as my root, I'm going to do synthetic division to see if it actually is a root. So I listed out 1, 1, -10, 8. And so I drop down the 1, multiply 1 times 1 gives me 1, 1 plus 1 gives me 2, 1 times 2 gives me 2, -10 plus 2 gives me -8, 1 times -8 gives me -8, that's a 0. So 1 is a root of that polynomial. Okay, so this polynomial then, I can write it as, so x cubed plus x squared, I'm just rewriting it, minus 10x plus 8 is equal to x minus 1, because 1 is a root, times what I'm left with. Remember, that's the remainder, that's the constant term, that's the x squared. So I have x squared plus 2x minus 8 is equal to 0. Okay, so let's factor this even further. What are the factors of -8 that add up to +4? You have 4 and -2. So I can factor this into x minus 1 times x minus or plus 4 times x minus 2. So what are the roots of this polynomial then? This one's going to give me x equal to 1. This one's going to give me x equal to -4, and that one's going to give me x is equal to 2. Okay, and those are the roots of that polynomial. Okay, over here, find the zeros of this function. By the way, if you do notice, the first thing you should be trying when you're doing this is if you have 4 terms, you should try to factor it by grouping, okay? A lot of these won't work out this way. That's just because of the setup of the problem, but that's the first thing that should jump into your head. Okay, so let's list out all the factors of p. Okay, so p is going to be plus or minus 1, plus or minus 2, plus or minus 4. And all the factors of q are going to be plus or minus 1, plus or minus 2, plus or minus 6. I don't know why I skipped over 3, plus or minus 3. Okay, so p over q is going to be in the form of plus or minus, so 1 over 1, comma, plus or minus 2 over 1, so 2, plus or minus 4 over 1, so 4. And then we're going to go plus or minus 1/2, plus or minus, so we did this one first. So we did 1 over 1, 2 over 1, 4 over 1. Now we're going to go 1 over 2, 2 over 2, which is 1, 4 over 2, which is 2, so I don't have to do that one anymore. And now we'll do the 6. So we have plus or minus 1/6, plus or minus 2/6, which reduces to 1/3. Plus or minus 4/6, which reduces to plus or minus 2/3. And then I have to do the 3. So I have 1 over 3, which is 1/3 I've already been given, 2 over 3, which I've already been given, and then I have 4 over 3. So plus or minus 4/3. So now we just have to check every single one of these, which is that. Now you can see why this is the awful part in this, right? Now, there's a thing in math called by inspection. And it's basically looking at it and making like what makes sense. If you look, if you just ignored the x's, 6 plus 4 is 10, plus 4 is 14, minus 14 is 0. So in other words, I'm pretty sure 1 is going to work in here. So let's start off with 1. Okay, so I'll do synthetic division with 1. So I'm going to write 6, 4, negative 14, 4, and then I just drop them down. So I have 6, 1 times 6 is 6, add them together, 10, 1 times 10 is 10, add them together, get negative 4, 1 times negative 4 is negative 4, and 0, so it goes in there evenly. Okay, so this thing right here, I'm going to rewrite, and I know 1 is one of my roots, so I'm going to write it as x minus 1 times what I'm left with. Well, this is the remainder. That's the constant term. That's the x, and that's the x squared. So this is 6x squared plus 10x minus 4. Now, I probably should have done this from the very beginning. Let's factor out what we can. These are all even numbers. So I could have easily factored out a 2 to begin with. I'm going to go ahead and do that now. So you notice a 2 goes into all those. It's the biggest factor of all those. So I'm going to bring it all the way out in front. And when I do this, I have 3x squared plus 5x minus 2 is equal to 0. Now I need to factor this. So I'm going to do it the method where I take the first times the last term. There's so many methods here, right? So you take the first times the last term and you get negative 6. And then what are the factors of negative 6 to add up to positive 5? We have positive 6 and negative 1. So I'm going to go and I'm going to rewrite this, but I'm going to rewrite it as 6 minus 1. Okay, so I have 2 times x minus 1 times this thing, which is 3x squared plus 6x minus x minus 2, and that's equal to 0. Okay, once again, I just rewrote 5 as 6 minus 1. Okay, just rewrote it there and there. Okay, so now I factor by grouping. So put parentheses are on the first two, parentheses are on the second two. It's starting to get pretty cluttered in here. If you wanted to take this to the side and work it out, that'd be totally fine. I'm going to continue on here. So I have 2 times x minus 1. Okay, so I'm going to put parentheses around the first two, like that. And then I'm going to put parentheses around the second two, but be careful because there's that minus. Okay, so when I put parentheses here, I need to switch that sign. Okay, now factor out what I can out of both of these. So I can take a 3x out of both of these. I'm left with x plus 2 minus, and there's the x plus 2. They both have an x minus 2. Ignore this if you need to. Okay, these both have an x plus 2, so factor an x plus 2 out of both of those. So I have 2 times x minus 1 times x plus 2, and I'm left with, when that happens, 3x minus 1. And this is equal to 0. So what are the roots here then? This one is going to give me x is equal to 1. This one's going to give me x is equal to negative 2. And this one's going to give me x is equal to 1/3. If you don't see that, remember what you do is you go 3x minus 1 is equal to 0, and then you solve. So plus 1, 3x is equal to 1, divide by 3, x is equal to 1/3. Okay, over here, find the zeros of this function. Okay, so once again, we're going to go about the same way. So p is equal to plus or minus 1, plus or minus 5. Q is equal to plus or minus 1 and plus or minus 2. So p over q, if there's a rational root, has to be in the form of plus or minus 1, so 1 over 1, plus or minus 1 over 2, plus or minus 5 over 1, and plus or minus 5 over 2. Okay, let's go up here and look at this by inspection, okay, if that makes sense. Okay, if you plug in a 1 here, it's not going to work, right? Because 1 is essentially just getting rid of the x's. Because you have 2 times 1 minus 1 plus 2. So if you plugged in a 1, you'd have 2, 4, 9 minus 1 is not 0. Now what happens if it's negative 1? Okay, if it's negative 1, this is going to be a negative 2. That's going to be a negative 2. So those two are going to add up to negative 4. This right here, when you square negative 1, is going to be positive 1. But you have the negative there. So negative 1 plus 5 gives you positive 5. Negative 4 plus 5 gives you 0. Okay, so negative 1 should be our root. So you have 2, negative 1, 2, 5. Go ahead and drop it down. So 2, negative 1 times 2 is negative 2. Negative 3, 3, 5, negative 5, and 0. And there it is. Okay, so I can rewrite this as x plus 1, because it was a negative 1, times 2x squared minus 3x plus 5, and that's equal to 0. And then once again, I need to factor this just like before. So what are the factors of 2 times 5 gives me 10. What are the factors of 10 that add up to negative 3, negative 5, and 2? Sorry, you can't see that. Okay, so I'm going to rewrite negative 3 as negative 5 plus 2. So I have x plus 1 times 2x squared minus 5x plus 2x plus 5 is equal to 0. Once again, just rewrote negative 3x as that. So I have x plus 1, and then I have 2x squared. Oh, factor by grouping, I'm sorry. So parentheses are on those two, parentheses are on those two. So you can factor in an x out of both of those, and you're left with 2x minus 5, and then plus, there it is, 2x plus 5. Close parentheses equals 0. Okay, factor 2x plus 5 out of this one and this one. The x plus 1 is still there. So I have 2x plus 5 times x. So that goes away, that goes away. There's a 1 there. So plus 1 is equal to 0. So my zeros are x is equal to negative 1. There's 1 there and there. And then this one's going to give me x is equal to negative 5 halves. Okay, why would it be that? Once again, you set equals 0 and solve. So you have 2x equal to negative 5, divide by 2, divide by 2, x is equal to negative 5 halves. Okay, and those are my zeros. Okay, so there's the rational root theorem. Like I said, it's not super fun to do this one. It's more of a pain, but it can come in handy if you get into a jam. Okay, thanks everybody. Take care. I'll see you soon.